Hi everyone, today we're talking about linear and nonlinear functions. As a reminder, you do not need to write down everything that we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause to jot down important notes, rewind to view information again, and fast forward if you think you already got it. Just be careful and make sure you don't fast forward too much that you end up missing out on something important. So functions can either be linear or nonlinear. So here are two examples. A linear function, as you can tell, makes a straight line for the graph. A nonlinear function does not make a completely straight line on the graph. They could also give you a table of the values, and that's like the x, y points, without the graph. So we're going to go over that as well. If you're just given the table of values, the xy values from your ordered pairs, you will need to calculate the slope, and the slope will let you know if it is linear or nonlinear. So if you remember calculating slope, you are subtracting the y's and you're subtracting the x's, and then you are dividing them. So change of y over change of x. So here, the y's are going up by 8 each time, and the x's are going up by 1s each time. That's the difference between the y values. So the differences of y's is on top, 8 over your differences of x, which is 1. 8 divided by 1 is 8. So we know it's going to be a straight line because it's always 8 over 1 each time you look at the values. For a nonlinear function, the slope or rate of change is not the same. So on one hand, I have 8 over 1 for two different pairs of points, and on another hand, I have 3 over 1, or 3, for two other points. So it's not a constant rate of change. Sometimes it's going up by 8, like really fast, and other times it's going up by 3, really slowly, and I imagine for this line it's going to go negative as well for other parts. The other thing you probably notice is that the equations look different. Linear functions always have just x to the first power, a normal x. And nonlinear functions are going to probably have x to a different power or exponent. Make sure you jot this down before we move on. So as a review, linear functions from a table of values, you can find out whether it's linear or not, because functions that increase at a constant rate of change, so same slope the entire time, are going to be linear. To figure out if it's a linear function from a graph, it's going to create a straight line, and that's because they have a constant rate of change. And as a review, here is the slope formula again. So again, pause the video and make sure you have this in your notes. All right, let's move over to some examples so that we can practice what we just talked about. In this problem, they want you to figure out, does the graph shown below represent y as a linear function of x? So it's just either a yes or a no. Go ahead and pause the video and try it on your own first. All right, so I see a straight line going across. It is completely straight. So I'm going to assume that it is yes, a linear function. The other way I could check, and this is totally not necessary, is I can create an XY table. So I'm going to figure out the ordered pairs, and just 3 points is fine. This is -4, -2, this is 1, -2, and this is 4, -2. So my xy's are -4, -2, 1, -2, and 4, -2. That's how we create the table of values. And remember, we have to figure out the slope. Slope is the change of y over the change of x. So I'm going to subtract my y's on top and then I'm going to subtract my x's on the bottom. And that's basically our rise over run. From our table, we can just do an easy subtraction here. To get from -2 to -2, I didn't do any changing. -2 to -2, also no changing. -4 to 1, let's see, I would add 5 to get there. And then from 1 to 4, I would add 3 to get there. So here it looks like it's not a constant rate of change, but remember it's the change of y over the change of x. So I have 0 over 5, that's this number and this number, and that slope is 0 divided by 5 is 0. The other slope is 0 over 3. 0 divided by 3 is also 0. So even though the x differences are not the same, we still get the same answer of 0. It is a constant rate of change. So it is linear because it's a straight line, and also because the slope always comes out to the same number. So is this a linear function? Yes. And that's two different ways that we figured out the answer. Again, you don't have to do all this. If you already have the graph, you can just eyeball it and see that it is a straight line. However, that's how you would create the table of values. Here's another question. Go ahead and pause the video and try on your own. Is this a linear function? All right, I see that this is not a straight line. It does a little dip. So I'm going to say that this is non-linear. If I wanted to create a table of values, let me choose some pretty points. That's also a pretty point, and that's also a pretty point. So I have -2, 6, 1, -2, and 8, -4. So -2, 6, 1, -2, 8, -4. And I'm going to calculate the slope, because later on for my slope I need the change in y over the change in x. 6 to get to -2, we would have to add 8. -2 to -4, we would subtract 2. And if you need a reminder on how to do that, you can just use your calculator. So literally what I can do is I can subtract. So 6 minus -2 gets me that 8. -2 minus my -4 gets me a 2. So it is getting smaller. And over here, this is going to add 3 to get there. 1 minus 8 is, or 1 to get to 8 is +7. Okay, so then if I were to calculate the slope, it would be 8 over 3 for one of them. And the other slope would be -2 over 7. Those two are not equal. So further proof that is nonlinear. So what this slope is showing me is that first it's positive, 8 over 3, and then it's negative. So it's literally decreasing and then increasing. So it's not constant. One last question. So here they don't give you the graph, so you're gonna have to use the slope that we talked about earlier. Go ahead and pause the video and try this on your own. All right, so just like before, we're going to calculate our changes in x and changes in y. Remember, the y differences go on top, and the x differences go on the bottom. Let me actually rewrite that. Okay, so again, we're subtracting 0 minus -2, or to get from 0 to -2, so that's going back 2 spaces. This is going forward 4 spaces. So if I had -2, It's going forward 1, 2, 3, 4 spaces to get from -2 to +2. 2 to -4, it's going backwards 4 spaces plus another 2 more. So it's going backwards 6 spaces. 3 minus 1, that's going backwards 3. This is going forward 6. This is going backwards 9. Okay, so my slope is my change in y over change of x. I have -2 over -3 for one of them. I have +4 over 6 for the other. And for the third one, I have -6 over -9. Now here they look like they're different, but I'm a little tipped off here that something's going on because I'm seeing a lot of numbers that are divisible. So first of all, that means I have to simplify. -2 over -3, I'm going to simplify them to positives because negatives and negatives cancel out to positive. This is slope, so we need rise over run. So I'm keeping them as fractions. Here I can reduce by 2, so I get 2/3. So far they're actually the same even though they look different. And this one, they're all divisible by -3. So this would actually be 2/3 as well. So all the slopes are the same. It means it's actually linear. They're going up at the same slope. They're always going up 2 and over 3. The whole way, all those slopes are the same. So it means it's going to go in a straight line at these different pretty points. They're always doing the same slope each time. So just because your slope doesn't look like the exact same slope doesn't mean that it's showing different slopes. You might have to reduce. Another way you can do it is just take out your calculator and divide those numbers. -2 divided by -3 is 0.666. 4 divided by 6 is that same number. And lastly, -6 divided by -9 is also the same number, okay? So they just look a little different. Okay, so let me know if you have any questions as you work on these. Remember, for the graph, you're just looking for a straight line. For a table of values, you're going to have to calculate the slope using the change of y, which is on the sides, divided by the change of x, which is on the other side. And remember to reduce to see if you actually do have the same slope. I will see you in class.